All right, friends, you have been tasked with preparing a scatter plot. How do you do it? Sounds scary. Don't always have to do it by hand. There's plenty of tools that are freely available on the internet. Look, if you want to use Excel, I use Excel all the time. You don't always need to. Certainly welcome to do that. And there's plenty of tutorials that are available online. However, Excel's fairly limited at the educational level, meaning there's not a lot of features that you can really do with Excel. So instead, what I want to do is just walk you through real quickly how to build a scatter plot in, I guess this would be Google Sheets, right? So if you don't have a Google account yet, just get one. They're free and their entire Office suite comes with a Google account. So as soon as you sign up for a Gmail account, let's say, it all comes with a Google account here. And you'll actually even see this up here in my, this is my quick links, I guess my bookmarks, Google Docs, Google Slides, and Google Sheets. I have those. Those are my go-to for really developing. And here's the best part. You can work them, they work fantastically. They are designed to work fantastically either on a computer or on a phone actually too. So I will do a little bit of work every once in a while on my phone using a Google product. Now that's not saying that Microsoft can't do that. It just seems to me that it tends to be a little more clunkier. And again, there's not many features that you can really do in the kind of the really basic bottom line level of programs like Excel. So again, if you know how to use Excel, great. I use it all the time, but don't feel pigeonholed into this. I just want to give you guys a quick, dirty overview. How do you prepare a scatter plot? And I have, you can actually see this on the page right here. This is data that's been collected. So this is the boiling temperature of pure water at various altitudes. This will eventually be the title of my chart here. And I've got two separate sets of columns that I have. So I have altitude. This is reported in meters. Okay, so you can imagine somebody went to various altitudes and then they tried to measure the boiling temperature of water. And then this is the actual temperature of water reported in Kelvin, right? So this is the absolute temperature of water. All right, so now we have to turn this into some sort of a scatter plot. How do we do that? It's not that bad. All you need to do is highlight your columns like this, and I will tell you, Google reads this first column as your x-axis, so it's going to read it as the independent variable. The y-axis is going to be that second column right here. So just sort of instinctively or sort of pre-programmed to read it that particular way. So to build your scatter plot as simple as possible, we just highlight the entire set of data, including the labels, and then we're going to go up here where it says insert, and we're going to look for chart. Google will instinctively read the data and go, okay, so this looks like this is probably a scatter plot of some sort. It definitely is in this particular instance. Of course, you can change the different types of data that you want here, but usually just a straight scatter plot will work just fine in scientific applications. All right, so we can see that we have our measured variable or our independent variable. Oh, this is killing me. Hold on. Let's move this into a new sheet. So we're going to actually make its own sheet right here. And oh, it looks a little bit bigger. Sorry about that. Looks a little bit bigger than how we have here. But what you'll notice is that this is temperature right here along the y-axis in Kelvin. You can see that. And then, of course, this is altitude in meters along the x-axis. Sorry, that's a neighbor of ours. All right, so first thing we need to do is we're going to have to go in and edit this chart. So it shouldn't be terribly difficult to do that. Remember, this is the boiling temperature for water at various altitudes. Okay, so you want to give your reader just a little bit of information as to sort of what's going on here. All right, so to adjust this, so we have our general setup that's going on right here. To adjust this and to start really making it our own, we go to the little tab over here that says Customize. So I'll go ahead and click that. And I'll start right up at the top, and this is just your general chart style. You can go ahead and change these colors as you want to. It's, however you want. It's not a big deal. We can take a look at the different axes as well too. I can alter the chart title a little bit. So maybe I wanted to change the chart title a little bit and maybe I wanted to increase the font size to, I don't know, 24. You can see that that actually brings the size of that up a little bit bigger. Maybe I wanted to change the color into maybe black and white so it's a bit more kind of stands out. You can certainly do that. If I wanted to bold it, I could do that. I could click the bold button right there. And then let's say I wanted to change let's say the horizontal axis. Okay, so this is the one that's down here. This is the x-axis right there. Maybe I want to, again, change the font color to black. And what if I wanted to increase the font size to 20? Okay, pretty easy to do something like that. No big deal. Then, of course, for completeness, we'll do the same thing on the y-axis as well, too. All right, so we've got that all kind of figured out. And so this is just kind of a way to sort of format your data a little bit. All right, so series, we don't have to worry too much about the series here. This is series corresponds to the number of, I guess, sets of plotted data. So in this particular instance, we're just looking at the temperature as a function of altitude. So that's the only data series that we're really taking a look at. So, if we were doing maybe one data plot for water and then one for ethyl alcohol and then one for hexane, those would be three different series right there. But this is just straight water, no problems, nothing terribly difficult about it. Although I will say, if you want to change the actual data plots, you can do that. So, maybe I want to make my data plots purple. I want to really make them pop out right there. Maybe I want to increase the font size of this, or the actual dot size, the point size, to 10. Really make those things point out a little bit here. I can change the shape if I want to turn these into diamonds, or if I wanted to turn them into, this is kind of cool, hexagons, whatever it is. I'm going to go back to circles. I like circles. And then we can kind of adjust the axes and all that kind of stuff here. But here's where the kind of the magic happens in chemistry classes, and that is we want to be able to put a trend line into this equation here. In other words, we want to be able to have the computer try to determine what the mathematical equation is that describes all of these data points here. And to do that, we click the trend line button. And of course, right off the bat, a nice straight line is drawn in here. But that's not very helpful. We need some information about that line. So how do we do this? We go down to where it says label, and we're going to actually change it to where it says use equation. And sure enough, in the upper and the top of this, you can actually see the equation for this line. Now, it doesn't look very much like an equation for the line because the format is y equals mx plus b. But the thing to understand here is that you have y is equal to negative 3.35 EE. That's times 10 to the negative 3 times x plus, and this is your intercept right there. Now, one other feature that's very important in chemistry is if you're going to put a trend line in here, you want to report how well the data points actually match that linear trend. And so we always want to put our R squared statistic in here. This is called the coefficient of determination, and this actually shows up right here. R squared equals 1. Remember, the closer the number is to 1, the more linear the data is. That is, that the data sits perfectly on that line. One other little trick that might be kind of helpful for you if you're kind of going through all this information is maybe you want to change the y-axis a little bit here so that it's a little bit, you see it ranges from 0 to 400. That's fine, but all the action's happening really between 300 and 400. So maybe I want to change the vertical axis from, maybe we'll make the maximum value 400 and we'll make the minimum value 300. Let's sort of see what happens when we do that. Oh, there you go. So it kind of spreads it out. And you can even go a little bit further if you want to. So maybe you make the maximum 375 and then the minimum is maybe 325. Really starts to spread that data point out. Oh, look at that. We could even make it 345 as well too. I am so sorry about that. There we go, nice and spread out here. And again, your equation is still up here with the R squared value as well too. So this is basically how you go about preparing these data plots. Pretty easy, pretty straightforward. All I need to do now is figure out a way how to print this or to download it. Pretty simple. Click File. We can send this over to download. And I can save this as an Excel file if I want to, but I'm going to do this instead. I'm going to download this as a PDF file, and here you go. This is the resulting PDF file that's right there. You can mess around with the formatting all you want to, but that's basically what you need right there. And we click export, and it drops into your download folder. And so now you have your PDF format. And you can always change that into a PNG file, or if you wanted to change it into a JPEG file or whatever, or screenshot it, whatever you want to do. But this is one of many ways of preparing plotted data. And I hope this video tutorial